Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing coordinate geometry and the equation of a line. This is part 2, so you should have watched part 1 before attempting to watch this video. We shall begin with parallel and perpendicular lines. A line joins the points A and B. Another line is parallel to AB, passes through the point 0, 7. Write down the equation of this line. So parallel lines have the same slope. So another line is parallel to AB. This means it has the same value of m, or the same slope or gradient. So we can get the gradient of AB, MAB, which is y2 minus y1 over x2 minus x1. So here this is x1, this is y1, x2 and y2. And we can get the gradient by plugging in the points. So for the y2, we have -2, y1 is 8, and x2, excuse me, this was a mistake. So x2 is equal to 2, and x1 is -3. So we have -2 minus 8 over 2 minus -3. -2 minus 8 is -10. 2 minus -3 is 5. -10 divided by 5 is equal to -2. So the slope or the gradient is -2. And since our line is parallel to AB, so our line has a gradient of -2 as well. And it passes through the point 0, 7. We said before that if x is 0, y is c. So y equals -2x plus 7. If you don't understand this technique, you can always use y equals mx plus b and plug in the point. So the m is -2, the x is 0, the y is 7. So 7 equals 0 plus c, excuse me, not b. So c is 7. So therefore, again, we plug 7 for c. So the final answer here will be y equals -2x plus 7. In the second question, we are told find the equation of the line perpendicular to AB, which passes through the point 1, 5, and give your answer in the form ax plus by plus c equals 0, where a, b, and c are integers. So we want a perpendicular line. So for a perpendicular line, the gradient is equal to -1 over the other gradient. So after getting the gradient, we flip it and switch it. So in our case here, the gradient of AB is -2. So we need to do two conversions here. So instead of negative, it becomes positive, and it becomes 1 over 2. Or if you want to just apply the equation, it becomes m2 equals -1 over -2, which is again positive 1 over 2. So either you apply the equation or you just flip and switch the gradient, switch the sign and flip the fraction. So now that we have our new gradient, we use this point here to get the equation of the line. So we write y equals mx plus b. And the gradient here is -2. Excuse me, I apologize. The gradient here is +1/2. And the x value is 1 from the point that we have. And the y value is 5. So, and I keep writing B instead of C because this is what I'm used to doing. But for IG, they use the letter C instead of B. I apologize if this is confusing. So 5 equals half plus C. So 5 equals half plus C. We can take the half x, plus C. I forgot to write the x here. So 5 equals half x plus C. I apologize, 5 equals half plus c only. So you take the half to the other side. So 5 minus half equals c. Therefore, c equals 4.5. Now that we have our equation, This is also 9 over 2. Now that we have our equation, we can write it in final form as y equals positive half x plus 9 over 2. This is the form y equals mx plus c, but they don't want this form in the final answer. They want ax plus by plus c equals 0. So we want the x and the y and the number to be on the same side, and we don't want any fractions. So we want to multiply everything here by 2 to get rid of the fractions. So the 2 cancels the 2, and the 2 cancels the 2 as well. So we get 2y equals x plus 9. And then finally, we want everything to be on the same side. So we're just going to take the x and the 9 to the other side. It becomes 2y minus x minus 9 equals 0. And this is our final answer. So 2y minus x minus 9 is correct. And negative 2x plus 7 is also correct. The line PQ has equation y equals 3x minus 8. Point P has coordinates 6, 10. Find the equation that passes through P and is perpendicular to PQ. So to get the gradient of this line, we just remember that we have this equation y equals mx plus c. So if the y is alone, if it's isolated, then the m is basically the number next to the x. So the m here is going to be 3. And since our line is perpendicular, let's call this m1. m2 will be negative 1 over 3. So now that we have our gradient, we use this point and we write down the equation y equals mx plus c. So the m is negative 1 over 3. And the x is 6. And the y is 10. And we want to get c. So 10 equals negative 1 over 3 times 6, which is negative 2 plus c. We take the negative 2 to the other side. So it becomes 12 equals c. So now that we have our value of c, we can write down the final equation as y equals negative 1 over 3x plus 12. This is our final answer. Point P is the point 16,9 and Q is the point 22,24. Find the equation of the line perpendicular to PQ that passes through 5, 1 and express as y equals mx plus c. So perpendicular means that we have opposite inverse slope. So first we need to get the slope of PQ. M1 is the slope of PQ. So we can write y2 minus y1 over x2 minus x1. And we plug in the values, but let's label the points first. So this is x1, this is x2, this is y1. And this is x2, and this is y2. So now we're going to plug in these points. So y2 is 24, and y1 is 9. x2 is 22, and x1 is 16. So 24 minus 9 is 15. 22 minus 16 would be 6. If we divide by 3 up and down, we get 5 over 2. So our new gradient or our new slope will be the opposite inverse of m1. So it's going to be negative 2 over 5. We switch the sign and we flip the fraction. And the point that our line passes through is 5, 1. We want to get the equation of the line. So we simply write y equals mx plus b. The y is 1. The m is negative 2 over 5. The x is 5. We want to get b. I did it again. It's c, because in IG we call this c, not b. Doesn't really matter, but I keep referring to it as b. So we cancel these out, and we have 1 equals negative 2 plus c, and then you take the negative 2 to the other side. So it becomes 3 equal to c. So therefore, the final equation will be y equals negative 2 over 5x plus 3. This is our final equation. And this here is the correct equation, y equals -2/5x plus 3. Line L passes through the points 0, -3, and 6, 9. Find the equation of the line that is perpendicular to line L and passes through 0, 2. So let's first get the gradient of L. Let's call this M1. M1 equals y2 minus y1 over x2 minus x1. Since we have 2 points here, so this is x1, y1, x2, and y2. So this is 9, and this is -3, and this is 6, and this is 0. So we have 9 minus -3, which is 12, over 6 minus 0, which is 6. And the final answer for this is 2. Now we can get the other gradient, M2, which is going to be -1 over 2, because we flip it and we switch it. So opposite inverse. And we have a point 0, 2, and we want to get the equation y equals mx plus c. So the m here is -12. The x is 0. The y is 2. And we want to get plus c. So 2 equals 0 plus c. So 2 equals c. So therefore, our final equation will be y equals -12 x plus 2. And this is the correct equation here. The diagram shows a straight line L. Find the equation of the line perpendicular to L that passes through 9, 3. So first we need to get the slope of L, or the gradient of L. Let's take 2 points. This here is 0, 6. This here will be 1, 4. So this is x1, this is y1, this is x2, this is y2. So the gradient, or the slope of L, equals y2 minus y1 over x2 minus x1. We plug in the values, so this will be 4, this will be 6. x2 will be 1, and x1 will be 0. So 4 minus 6 is -2 divided by 1, which is -2. Now to get the perpendicular slope, let's call it M2 or whatever, we switch the sign, so it becomes +2, and we flip the fraction, so it becomes 1 over 2. So the new gradient or slope is half, and the point is 9, 3. To get the equation, we just write down y equals mx plus c, and we substitute. So 3 equals half times 9 plus c. 3 equals 4.5, or 9 over 2 plus c. You take this to the other side. So you get c equals 3 minus 9 over 2. You can use the calculator if you're allowed one, or you can write 3 as something over 2. So 3 equals, you just write over 1 here, and you multiply by 2 up and down. So you get 6 over 2. So c equals 6 over 2 minus 9 over 2, which is -3 over 2. Now that we have the m and the c, you can write down the equation as y equals mx plus c, which is y equals half x plus -3 over 2. This is our final answer. This in particular is our final answer. Let's check the marking scheme. So half x minus 1.5 is exactly the same as what we wrote. It's just written in decimals instead of fractions, but of course both answers are correct. So again, here we have 2 points C and D, and we want the line that is perpendicular to CD and passing through 1, 3. So first, let's get the gradient or slope of CD. y2 minus y1 over x2 minus x1. And we use the 2 points. Let's label their coordinates. This is x1, this is y1, this is x2, and this is y2. So y2 is going to be 7 minus y1, which is 2, over x2, which is 9, minus x1, which is -1. So 7 minus 2 is 5. 9 minus -1 is 10. If we simplify this, we get 1 over 2. So our new gradient or slope will be negative 2 over 1. This is our M2 or our new gradient. Now we have this point 1, 3 that we're going to use to get the equation of a line. We write down y equals mx plus c. We put the x as 1, and the y as 3, and the m as negative 2. So 3 equals negative 2 plus c. Take it to the other side. So 5 equals c. So finally, y equals negative 2x plus 5 is our final answer. Show that the line 4y equals 5x minus 10 is perpendicular to the line 5y plus 4x equals 35. So this is slightly different. We just want to show that they're perpendicular. So we need to get the slope or the gradient of each. Remember that one of the nice ways to get a gradient is to just try to write the equation in the form y equals mx plus c. And this will automatically enable us to identify m. So here we have 4y. So we need to just divide everything by 4. So y equals 5 over 4, x minus 10. And m1 here is just 5 over 4. It's the number next to the x. We're going to do this exact same thing for this other line. So first we isolate. So we take the 4x to the other side. So we have 5y equals negative 4x plus 35. And then we want to divide by 5. Just divide everything by 5. And we get y equals negative 4 over 5 x plus 7. So m2 is simply negative 4 over 5. And to show that they are perpendicular, we just show that m1 times m2 equals negative 1. So m1 is 5 over 4, and m2 is negative 4 over 5. These cancel out and these cancel out, so we're just left with negative 1. So the final answer is negative 1. Therefore, they are perpendicular. Because we said that for perpendicular lines, m2 equals negative 1 over m1. And this is exactly the same as saying m2 times m1 equals negative 1. So you just show that one of them has a gradient of 5 over 4, and the other has a gradient of negative 4 over 5, and the product is negative 1. This is sufficient to prove that they are perpendicular. Find the gradient of the line that is perpendicular to the line 2y equals 3 plus 5x. So again, we need to first find the gradient of this line. So we divide everything by 2. So y equals 3 over 2 plus 5 over 2x. Some of you may be tempted to say that this is the gradient. Of course, this is incorrect. We don't take the first number that we see. We take the number that is next to the x. So this is actually the gradient. It's 5 over 2. So therefore, our gradient will be negative 2 over 5. So m2 will be negative 2 over 5. And this is the correct final answer. Next, we move on to midpoint and distance. A line joins A to B, find the midpoint of AB. So you need to know the formula for the midpoint. The formula is simply the average of x's and the average of y's. So x1 plus x2 over 2, comma, y1 plus y2 over 2. x1 and y1 and x2 and y2 are simply the labels of the points again, like we used to do before. So this is x1, this is y1, this is x2, and this is y2. We just plug them into the formula. So x1 is 1, x2 is 5, y1 is 3, and y2 is 8. So 1 plus 5 is 6, 6 over 2 is 3, 3 plus 8 is 11, 11 over 2 is 5.5. So our point is 3, 5.5. And this seems to be the correct answer here. A line joins the points A and B, find the coordinates of the midpoint. So again, the midpoint is just the average of x's and the average of y's. So x1 plus x2 over 2, comma, y1 plus y2 over 2. So x1 here is negative 3. Let me label them first. I apologize about that. So this is x1, this is y1, this is x2, and this is y. I mixed them up. I apologize. This is x2 here, and this is y2. And then we just plug them into the formula. So x1 is -3, x2 is +2, y1 is +8, y2 is -2. So here we have -3 plus 2 over 2, and 8 plus -2 over 2. So -3 plus 2 is -1, so -1 over 2. 8 plus -2 is 6, so 6 over 2. And this becomes -0.5, 3. And this is the final answer. -0.5, 3 is the correct answer here. A is the 0.712 and B is the 0.2, -1. Find the length of AB. So we covered the midpoint. Now we're going to cover the distance or the length of a line. The distance formula looks like this. D equals root of x2 minus x1 squared plus y2 minus y1 squared. And again, we labeled the points. So we have x1, y1, x2, y2. And we want to plug them into this formula. So x2 is 2. So let's write down the square root. Now x2 is going to be 2 minus x1, which is 7 squared, plus y2 is -1 minus y1, which is 12. And this also is raised to the power of 2. Now we simplify. So we have root of -5 squared plus -13 squared. Of course, you can use your calculator to figure this out. I'm going to write them on the calculator now. So -5 squared plus -13 squared. Of course, on the calculator, you can either ignore the negative because you know that the power 2 will cancel the negative, or you put -5 in brackets and you put the power 2 outside. Because if you write it on the calculator like this, you're going to get error because you're going to get a negative value inside the root. So this does not make sense. And you should not use it, of course. You should either just cancel out the negatives or put the -5 in a bracket, but make sure that the power 2 is outside. This would also work. So the final answer is 13.93. And this is the correct answer as well. Again, we have 2 points here and we want to find the length of AB. So we first write down the formula for length or distance, which is D equals root of x2 minus x1 squared plus y2 minus y1 squared. And we plug in the values. So we have x1, y1, x2, and y2. So D equals root of x2 is 9 minus x1, which is 2 squared, plus y2, 4, and y1 is 1, so 4 minus 1 squared. So the distance is equal to root of 7 squared plus 3 squared. And this is equal to root of 30, which is 5.477, or just 5.48. This would be okay as a final answer. I seem to have made a mistake in the final calculation. This is not root 30. I just did it mentally and this was a mistake. So this is actually root 49 plus 9. So this is root of 58, which is actually 7.6. This is the problem with trying to do things mentally. So 58 here would be 7.62. Root of 58 would be 7.62, and this is the correct answer here. Here we have 2 points and we want both the length and the midpoint. So let's start with the length. The length is d equals root of x2 minus x1 squared plus y2 minus y1 squared. So let's label the points. This is x1, y1, x2, and y2. We put x2 as -4 minus x1, which is +8 squared, plus y2, which is 1, minus y1, which is 5 squared. So -4 minus 8 would be -12 in a bracket, power 2, and 1 minus 5 is -4 in a bracket, also power 2. So either you ignore the negatives because the power 2 will cancel them out, or you put them in proper brackets. Otherwise, the calculator will miscalculate. So here the final answer will be 12.65 for the distance. For the midpoint, we use the midpoint formula, of course. So m is x1 plus x2 over 2, comma y1 plus y2 over 2. We use the same labels as before. X1 is 8, x2 is -4, y1 is 5, and y2 is 1. So we have 8 plus -4 is 4, 4 over 2. 5 plus 1 is 6, so 6 over 2, which is basically 2 and 3. So 12.65 is correct for I, and 2, 3 is correct for I. This brings us to the end of our video. I hope this has been beneficial. Thank you for watching.